and gentlemen. Today we're talking about section 2.6, which is proving statements about segments and angles. We haven't really used that word prove before, but we're going to talk about it a little bit today. But first, let's look through a couple of real-life situations. We're going to combine the things we talked about with deductive reasoning and if-then statements and postulates and properties and kind of all combine it into one today. So here we're given a fact that Roxy is a German Shepherd. We're trying to prove that Roxy will not lay eggs on the 4th of July. This may seem silly, this may seem like a ridiculous statement and that it's obvious, but we need to map through step by step what our evidence is. The reason being is that in geometry, when we're trying to prove something, we're kind of acting like an attorney that's trying to prove a case. And to prove a case, attorneys use evidence. They use things like expert testimony, they use circumstantial evidence, DNA, they use all different kinds of things, and they go through step by step. They don't just go to the judge or jury and say, it's obvious. So we're not going to do the same thing. We are also going to use evidence. So here, Roxy is a German Shepherd. Well, a German Shepherd means that Roxy is a dog. So I'm going to list my evidence here before I write any sort of argument. Because Roxy is a dog, that means that Roxy is a mammal. Because dogs are mammals. Mammals do not lay eggs. So Roxy is not going to lay eggs on the 4th of July. It almost looks like the law of syllogism. If Roxy is a shepherd, then Roxy is a dog. And I probably should have written that shepherds are dogs. And Roxy's a shepherd, and shepherds are dogs, Roxy's a dog. If Roxy's a dog and dogs are mammals, Roxy's a mammal. If mammals don't lay eggs, then Roxy doesn't lay eggs. So if I were going to give some type of argument, what I would have to do is write maybe a 1 to 3 sentences explaining my argument based upon this evidence. So Roxy is a shepherd, which is a type of dog. Dogs are mammals, and mammals do not lay eggs. So Roxy will not lay eggs on the 4th of July. There's an example. Now, if you write an argument, it might look slightly different. You might write it in a more condensed fashion to where it's shorter, but as long as you have all the needed information and you're using complete sentences, that would be a valid argument to prove that Roxy will not lay eggs on the 4th of July. Again, we listed all of our evidence, and that's how we can consider this to be a proof. Another life example is you forgot to set your alarm clock and you already have 5 tardies. I want you to prove that you will not be able to go on the NIU field trip. If I were to go through all the steps of logic, well, if you forgot to set your alarm clock, then your alarm won't wake you up, so maybe you'll oversleep. If you oversleep, then you'll be late for class. Whether you missed the bus or you just didn't have enough time to get dressed and brush your teeth and eat breakfast and things like that. So if you forget to set your alarm clock, you'll oversleep. If you oversleep, you're late for class. If you're late for class, in this case, you already have 5 tardies. That would be your 6th tardy. And according to the rules, you will not be able to go to the NIU field trip. So if I were to write some sort of argument based upon the evidence we listed and kind of planned our way to prove this, we would say that if you forget to set your alarm clock, then you will oversleep and be late for school. Or just you will be late. This will be your 6th tardy, so you will not be able to go to NIU on the field trip. Again, it's an obvious thing to us, but we need to list every logical step in order to make this a proof, in order to have an airtight case as an attorney, so to speak. Now for the formal geometry stuff. A proof is basically just a logical argument that you've written that shows a statement is true. So we just showed that Roxy's not going to lay eggs on the 4th of July, and we just showed that you will miss your field trip. Some resources that you can use for proofs are, 1, In a geometry proof, you're always given some information you can use. Like the fact we were given that you already had 5 tardies. We could use that to conclude that your next tardy would be your 6th tardy. In geometry, a lot of times given information is your picture. A lot of times you can use your picture. And the second piece of information you can use as a resource is any postulates we've talked about, or properties like subtraction property of equality, or substitution, or transitive. Any theorems, which we haven't talked about yet, we'll talk about in the next lesson, and any definitions. We've talked about lots of definitions from Chapter 1 that you can use, like the definition of complementary angles, or supplementary angles, or perpendicular lines, or congruent angles, and things like that. Those definitions are very important. So let's do a couple of examples of proofs, just a couple. We'll go through a lot of them in class. This, again, video just as a little tutorial for you if you were absent, which so far no one's been absent today. We'll see if anybody misses later on. One example, and we're not going to write a 2-column proof. That's more the things that I would do in a formal geometry class. We're doing more informal paragraph explanations here. So if we're given that the measure of angle A equals the measure of angle B, the measure of angle B equals the measure of angle C, we're trying to prove that angle A is congruent to angle C. Well, you might already see it, that we know that these measures are all equal, and they both contain the measure of angle B. This looks just like our law of syllogism or our transitive property, which says we can cut out angle B and just say that measure A is equal to the measure of angle C. And that we use the transitive property. But we still want to show that A equals or is congruent to C. Well, here this looks a little different. We have measures and we have equals, not congruent. Well, back from section 1.4, we talked about the definition of congruent angles, which says if these have the same measure, then they're congruent. So I can say, well, they have the same measure, so I can logically conclude that they're going to be congruent. So angle A is congruent to angle C. And that is using our definition of congruent angles. Now again, it seems so obvious. Well, if A equals B and B equals C, sure, they're all equal. And if they're equal, they're congruent. And we just map that out with the transitive property and the definition of congruent angles. So as like a brief explanation of this, because you have to provide me with something here as an explanation, you could say something along the lines of, you know that the measure of angle A equals the measure of angle C due to the transitive property of equality. And then angle A, if I can write this correctly, typing here, angle A is congruent to, and this might look, yeah, this is going to look different, that's okay, to angle C due to the definition of congruent angles. And there we are. So again, you're writing something, an informal something here, to prove that those two, or that last statement, I'm sorry, is true, that angle A is congruent to angle C. We know that because of the transitive property and the definition of congruent angles. Let's take a look at another one. We know that angle 1 and angle 2 are complementary. We want to prove that those two rays here, or as I labeled them as lines, these two lines are going to be perpendicular. Well, let's think about this logically and map out a plan. We know that 1 and 2 are complementary, so this should be a right angle because they add up to 90. And if this is a right angle, then we know the lines are perpendicular because perpendicular lines are formed when two lines intersect to form a right angle. So that's true, okay? Our proof statement will always be true. We just have to show why it's true. That's the whole point of this. So 1 and 2 are complementary, which means that if I add the measures of 1 and 2 together, it should equal 90 degrees. And 90 degrees, oh actually, well I should say this is the definition of complementary angles, which says that complementary angles add to 90. I also know that a 90-degree angle is a right angle. So if I add these together, it should equal a right angle. That's the definition of a right angle. Well, if these two together form a right angle, and this is in fact a right angle, then we can conclude that the lines are perpendicular because the definition of perpendicular line says they're formed by two lines making a right angle. So I'll say that line BA is perpendicular to line BC And that's because the definition of perpendicular lines, which says if they intersect to form a right angle, they're perpendicular. So again, just an informal explanation explaining your logic of how you know this proof statement is true, or why you know this is true, all right? So for a couple of sentences, and let me change the font here because I like my cool font, Chalk Duster. So we can say that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Or because or due to the definition of complementary angles. And we can say that they form a right angle since 90-degree angles are right. That's the definition of a right angle. And lastly, we can say the lines are perpendicular due to the definition of perpendicular lines. Or you could say instead of that, they're perpendicular because the two lines form the right angle. Either way, some sort of explanation informally using evidence, theorems, postulates, and definitions, things like that, properties to back up your claim. All right, so to prove it, you have to use that sort of evidence. So this is an example. Yours might look slightly different. Hope this was slightly helpful with just a couple of examples. We're going through a lot in class, but this isn't something we're going too deep into. It's just good to be exposed to and to know how to form a logical argument. We do much more of these in chapter 3 and chapter 4.